Now we're going to start looking at sorting algorithms. And sorting is one of the most fundamental operations in computer science. Basically, the sorting algorithms allow us to organize data in a particular order. Usually, we deal with numerical data, lexicographical data, but the reason as to why this is important is because sorting makes it easier to search, analyze, and manage data efficiently. And in a number of applications, we deal with lots of databases when we build applications and systems, talk of e-commerce sites, talk of the search engine. We need a way to basically search, analyze, and manage data in these systems efficiently. And over the next few videos, we're going to be looking at the sorting algorithms. So we're going to start with the sorting algorithms that are a bit more not as efficient. So things like we're starting with bubble sort, going to selection sort, insertion sort. Then after that, we'll start looking at more efficient algorithms that we can use to sort our data. Now, starting with bubble sort is probably one of the simplest sorting algorithms. And the idea here in bubble sort is basically to compare adjacent elements in a list and swap them if they're in the wrong order. So the larger elements basically bubble up to the end of the list, just like basically bubbles rising from the surface. And we're going to be using this as the example of a list that we're going to be using. And as you can see, notice here, this list is unsorted. And we're going to see how bubble sort works to basically sort this list and bubbling up of elements. So how it works, and I'm going to be just explaining this process as I write it down here. Let's just continue the blue. So how it works, the first step that we follow is we start from the beginning of the list. So start from the beginning of the list. And the next step that we do is we're going to compare each pair of adjacent elements from the beginning of the list. So basically compare each pair of should be each pair of adjacent elements. And after doing this, as we do this comparison, we're going to basically check if they're in the wrong order. And if the elements are in the wrong order, we basically swap them. So just write this here first, swap if in wrong order. So for example, in the array that we have here, these elements we start from the beginning here, and in this case it's 10. We compare with the adjacent element, which is 1. And as you can notice, these two are in the wrong order. So we're basically going to go ahead and swap them. So we're going to move 10 here, and 10 is going to move here. We do that swapping like that. And then let's proceed to the next step. The next step after doing the swap is to basically repeat the process for every element from left to right. So basically repeat for every element from left to right. So this process of swapping you're going to repeat for every element. And basically after each pass, the largest element basically is in its correct position after you've already done this. So for example, in this case, 11 will be the largest element. So in this case, once 10 has moved here, we check 10 and 11. We realize that, okay, these two elements are in the correct order. We move to 11, we check 11 and 0. Then we realize like, oh, okay, 0 is smaller. So we do the swapping. Then we repeat the process again until now 0 is going to be the smallest element, moving all the way to 1 being the largest element. So we're going to go ahead and also look at another example. We're just going to take another crack at this. So let's have an example of a list. Let's have an example of a list like that has elements like 5, 1, 4, 2, and maybe 8 at the end. And we want to apply a bubble sort to do this. So in the first, we're going to compare. So at first, we're going to start and compare 5. We're going to compare 5 and 1. Then since 5 is larger, we're also going to swap them. And now the new list is going to be 1, 5, like that. Then we're going to continue comparing all these other adjacent pairs until the largest number, in this case, which is 8, reaches the end of the list. So in our case here, we're lucky that 8 is at the end of the list. So that's okay, but the process is the same, and we continue that process until the entire list is sorted. Now, what we're going to do is we're going to write some Python code on how to implement this. But again, from the process that we've described here, you can comfortably apply this implement this rather in any other programming language of your choice. So, but to do it in Python, we're going to create basically we're going to define a function here. It should be bubble sort, and this this function is going to take an array as its parameter. And then we're going to first of all start by checking the length of the array. It's not really compulsory to check it at this point, but let's do it anyway. So we're going to check the length of the array, and this is going to help us in iteration. Then the first thing we do is now iterate. So we're going to say for I in range, that now the range is going to be, of course, the length of the array. Then after iterating through the array, we're also going to have a second iteration here. So we're going to just say for j in range, and in this case now the range is going to be from 0 up to n minus i minus 1. And then now from here, the next thing we're going to do is, now that we've done both iterations, we're going to basically check if the element that is at basically index j is greater than the element that is at index j plus 1. And how we do that, just say if. Just a simple if statement. Okay, I like using the parentheses. So just say if element, the array at index j, if the array at index j is greater than the array at index j plus 1. So at index j plus 1, I should use need 2 r's here. So if this is the case, then we're going to go ahead and swap. Again, we've checked if the array at index j is greater than the one at index j plus 1. So, and basically how you look at it is in this case. So if this is j, so this is j and this is j plus 1, and we're comparing the two. So if this is greater than this, we do the swapping, and that is what you're doing here. So we just do the swapping. So you just take array at index j. You can just do all of it at once here, and then we check array at index j plus 1. Not really check, but we're doing the swapping. And then basically, so j will be matched with j plus 1. Then j plus 1 is going to be matched with j. So we just say array at index j. And let me just reduce the font. I had a bigger font so that it's a bit clear to everyone what I'm writing. So now that we have this, basically this is how this is enough to do bubble sort. To just run the code. Oh, we need to basically call our function this, and I'll just print it out as I call it. So we print bubble sort. So bubble sort, and then we pass in an array here. So let's pass in our array, which is 51428, 514, and 8, like that. So we have this, and basically we are sorting everything. So we're going to do Python 3. We're going to do Python 3, then bubble sort dot py, and let's run it. Okay, so it's returning, and the reason it's returning none here is because, of course, we haven't returned the sorted array. So we just go ahead and return array here. Simple as that, and that fixes everything. Now if we run it again, you see now we have our array sorted, as you can see here. And in a nutshell, basically, that is basically bubble sort. And yeah, we're going to go ahead and look at the next sorting algorithm.